have geometry reviews. Okay, we review on some definitions. So first of all, like some vocabularies. So angle at a point. If you talk about the angle, we can talk about complementary, supplementary, revolution, and vertical offset angles. So what is complementary? So complementary angles are the angles sum to 90 degrees. Let's say that's 90 degrees and we have angle alpha and angle beta. They are supplementary angles. Okay, they are supplementary angles, complementary angles. And then supplementary angles are sum to 180 degrees. 180 degree will be a straight line. Okay, so we have two angles on it. Let's say we have alpha here and we have beta here. They are supplementary angles. Okay, those two angles are supplementary. Or you can have three angles. They all add up to 180. They can be supplementary angles as well. Okay, so revolution is the angle have 360 degrees, which is turn around. So which talk about this angle here. So that's a revolution angle, which is 360 degrees. And what is vertical offset? So you have two straight lines, they cross each other. So like this. And then this one and this one, they are opposite, vertical offset. And this one, they are vertical offset. So the vertical offset angles are equal. Okay, the vertical offset angles are equal. Yeah, two straight lines, they cross, they can make four angles, and the opposite ones are equal. Okay, so we talk about angles in a parallel line. So if we have two lines A, B, and CD are parallel, we write AD parallel to CD. So alternate angles are equal. So what are alternate angles? Let's say we have two lines A, B, and CD, and they are parallel lines. Okay, they are parallel lines. And then we have another line cross those two lines. Okay, so what is alternate angles? Alternate angles are the angles looking for the Z shape. Okay, so we're looking for the Z shape. So what can be a Z shape? Can you see this green one? That's a Z shape. Okay, so in the two corners, those two angles must be equal. So that is alpha, that will be alpha as well. Okay, that's looking for the Z shape. We can look for other Z shapes as well. For example, we can look for this Z shape. You can see there's a Z. Okay, we can looking for this Z shape. If that's Z shape, that's beta, and this one will be beta as well. Okay, we can find two pairs of alternate angles in this diagram. Okay, so we're looking for corresponding angles. If we have the same situation here, okay, if we have the same situation here, and we have a line cross that, let's go for this way this time. So let's say A, B, and C, D, and we have a line cross that, and we're looking for corresponding angles. We're looking for F shape. Okay, we're looking for F shape. So what can be an F shape? That's two. So this can be an F shape. You can see this F. Okay, in this F shape, the two angles in the corner will be equivalent. Okay, I can also find other F shapes. For example, this one, that's a reflected F shape. Still the same position, you can have equivalent angles. I can also find, for example, F shape here. That's an inverted F shape. See this black lines? Let's say that's sigma, and that one will be equivalent. And also those two will be equivalent because that's another F shape. Okay, that's another F shape. Those two will be equivalent as well. Okay, so we can find four pairs of corresponding angles here. Okay, you must have AB parallel to CD. If AB is not parallel to CD, they are not equal. You can still have corresponding angles. For example, let's draw a line like this. Those two lines are not parallel. Okay, those two lines are not parallel, and the line cross that. Okay, this angle, like this angle here, and this angle here, they are still called corresponding angles because that position is corresponding. Okay, that position is called corresponding position. They are still corresponding angles, but they are not equivalent because those two linear are not parallel. Because AB is not parallel to CD, so those two corresponding angles are not equal. Okay, in parallel lines, corresponding angles will be equal. They're still called corresponding angles, but not equivalent because AB is not parallel to CD. Okay, the next one is co-interior angles. That two angle must be supplementary. So supplementary, okay, supplementary is sum to 180 degrees. So where is co-interior angles? I call this angle C shape. Okay, that's a C shape. Okay, let's say we still have those two lines, AB parallel to CD, and looking for C shape. So what can be a C shape? That can be a C shape. Okay, that's a really squared C, but like that's a C shape. So those two angles, alpha and beta, so alpha plus beta must give you 180 degrees. Okay, we can also find another C shape, which is this side. Okay, that's co-interior. Let's say that's A and that's B. So A plus B must be 180 as well. Okay, A plus B must be 180 as well. Okay. Let's do next one. Okay, in geometry topic, we have a lot of proof. Okay, we have a lot of proof questions. Okay, do not assume something for proof. Like, you must show everything, all the reasons, and then you give a conclusion. Do not assume, I know this, I know this. Okay, so let's do a proper proof. Okay, I will show you how you can do a proper proof. Let's say triangles. Angle sum is 180 degrees. Try to prove for that. Let's just draw a triangle. Okay. Do not draw special shape, just draw regular triangles with vertex A, B, C. Okay, with vertex A, B, C. I'll draw a line DE, pass through the point A. Okay, I'll draw a line DE, pass through the point A, which is DE parallel to BC. Okay? I'll say like here, pass point A, draw line DE, which DE parallel to BC. Okay, which DE parallel to BC. So I have from point A, I'll draw a line DE, and then DE will be parallel to BC. Okay, so now you are going to talk about three angles. Let's say alpha, beta, and sigma. Okay, you say because DE parallel to BC, so angle DAB will equivalent to angle beta, angle EAC will equals to angle sigma. So that one will be this, and this one will be beta because of the alternate angles. Okay, I hope you can see that's an alternate angle. Okay, Z shape. Okay, I'll draw this one. That's a Z shape. Can you see that? That's a Z shape. So the beta will equivalent to beta. So you have alternate angles. And then you can say angle alpha plus angle beta plus angle sigma will equivalent to angle alpha plus angle DAB plus angle EAC. Okay, because you change beta to DAB and change sigma to EAC. And that will give you 180 degrees. Right? Because it's a straight line. Okay, it's on the straight line. Okay, they are supplementary angles. Okay, they are on the straight line. So straight angles. So some angles in triangle is 180 degrees. Okay, you have proof that you sum all those three angles, and those three angles will give you 180 degrees. So therefore, sum of any triangle with the same shape triangles, you will have inner sum will be 180 degrees. Okay, next one. So triangle can be classified in three groups and can decide by two things. Okay, we have different names for triangles. So first one, let's say triangle classified by angles. Okay, triangle classified by angles. I'm looking for angles. So acute. So we have acute triangle. So acute triangle can be all angles acute. Okay. So all the angles less than 90 degrees, I can have a triangle like this. Okay, all less than 90 degrees. I can have obtuse, which is one angle is obtuse. For example, like triangle like this. Okay, obtuse, that angle is obtuse. I can only have one angle obtuse because I cannot have two. If two angles over 180, the sum will be over 180. If each angle greater than two angles greater than 90, then the sum will be greater than 180. And we know the sum of triangles can only be 180, so I cannot have two obtuse angles. So the other two must be acute. And then right angle triangle, so we're very familiar to that. That's a right angle. Okay, that's a right angle. Okay, next one. Angles classified by set length. Okay, I'm not looking for angles now. I'm looking for the set length. Okay, scaling. So three different sides. Okay, I have triangle with three different sides. Okay, it can be say like this. Okay, all different. Okay, all different sides. Okay, so do you think scalene triangles can have? Okay, can I have a acute scalene triangle? Can I have a acute scalene triangle? Yep. Can I have obtuse scalene triangle? Yep. And a right scalene triangle? Yep. Okay, so I can have like there's not influence each other. I can have a scalene, but like they can be acute, can be obtuse, and can be right angled. Okay. The next one is isosceles triangle. Okay, isosceles triangle we have two equal sides. Okay, so we can have, let's say this one, that's an acute isosceles triangle, and we can have obtuse isosceles triangle, and I can have right angled isosceles triangle. Okay. For equilateral triangle, it's three equal sides. Okay, that's acute. Can I have obtuse equilateral triangle? No. Can I have right angle equilateral triangle? No. Okay, the three angle must be 60 degrees. So I can only have one type for equilateral. Okay, only the acute. Okay, if it's an equilateral triangle, it must be an acute triangle. Okay, so next one is quadrilaterals. So what are quadrilaterals? With 4 sides, okay? Shape with 4 sides. So we have parallelogram. So what is parallelogram? We have 2 sides parallel. Okay, we have a shape that this one parallel to this one, and this one parallel to this one. Okay, 2 pair of parallel lines. Okay, 2 pair of parallel lines, which is a parallelogram. Okay, a rectangles. Okay, a rectangle is a parallelogram. Okay, a rectangle is a parallelogram because it satisfies that we have 2 pairs of parallel lines. Okay, there's one thing special for rectangle, which is 2 diagonals are the same. Two diagonals are equal. Okay, 2 diagonals are equal for this. Okay. And the intersection point of the diagonals will be the midpoint of 2 diagonals. Okay, will be the bisection bisects the diagonal. Okay, square. Square is a special type of rectangle because it with 4 angles with 90 degrees. And it's also a parallelogram. Okay, it is also a special type of parallelogram because it's got 2 pairs of parallel lines. Okay, and also the diagonals are equal. The diagonals equal, and diagonals are perpendicular. Diagonals are perpendicular. Okay, diagonals perpendicular to each other. In the triangle, a rectangle, the diagonal not perpendicular, but in the square, the diagonal will be perpendicular. Okay, the diagonal will be perpendicular. Okay, I have rhombus, which is parallelogram with side of equal length. So it's a special type of parallelogram. Okay, it's a special type of parallelogram. Okay, with 4 sides of equal length. Let's draw it that way. Let's see. Okay, it looks like a rhombus, but like you know that 4 sides should be equal length. Okay, if 4 sides with equal length, okay, the important thing is the diagonal perpendicular to each other. Okay, diagonals are perpendicular to each other. And diagonals are bisects each other. Okay, bisects each other, cut into half. Okay, exactly meet at the middle points. Okay, bisects each other. And the next one is a kite. So what is a kite? A kite is with 2 pairs of equal adjacent lengths. Okay, 2 pairs of equal adjacent lengths. So we can have okay, that's a kite. This looks bad, but like that's a kite. So this one will equals to that one. Those 2 will be equivalent. And the diagonal perpendicular. Okay, the diagonal perpendicular. diagonal perpendicular, but not bisects. Okay, not bisects. You see which one? This one will be bisects, but like the other one will not be bisects. So one diagonal will be bisects and the other one will not. Okay, a trapezium. So a trapezium is one pair of parallel lines. So it's only have one pair of parallel lines. If you have two pair of parallel lines, then that will become a parallelogram. So a trapezium will be like this. That's a trapezium. So they're parallel to each other. Or I can say that is trapezium as well. Okay, this one parallel to this one. Okay, so let's make a summary about this. Okay, where I can write it. I will write at the bottom here. So we have quadrilaterals. Okay, so quadrilaterals can have parallelogram. Okay, and this type is a parallelogram. So under parallelogram, we can have another two special ones. We have rectangles and we have rhombus. Okay, we have rhombus, and those two can give you another special one, which is square, because square share the property for rhombus, which 4 equal lengths, and also have the same property as rectangles, have 4 90-degree angles. So square will be special type, and the rectangles, rhombus, and also parallelogram. And we can have another like other types. The other types will have trapezium, and we have another one is kite. Okay, we have others. We have trapezium and we have kite. Okay, that's the relationship between all the things we talk about. So parallelogram is a big group. Okay, rectangle, rhombus, and square all belongs to parallelogram. And we have others. Trapezium is not a parallelogram because only have one pair of parallel lines, and kite will not be a parallelogram because the two sides are not parallel. All right. All right, let's have a look at this one. The next one is polygons. Okay, we have polygons. We have how many sides? If you have 3 sides, we have that's a triangle. If it's 4 sides, we said that's quadrilateral. If there's 5 sides, we said that's a pentagon, and 6 sides hexagon, and pentagon, octagon, nonagon, and decagon. So we have different names for like 3 to 10. We're not going to talk about 11 sides. Okay, that's too much. So polygons are angle sum, like have an angle sum given by this formula. Okay, where n is the number of sides. I want to prove for this. I don't know like how I can prove for it. I'll give an example. Let's say we have how many sides we have for this shape? 1, 2, 3, 4, 5, 6. Hexagon. Okay, we have a hexagon. Let's say we choose a point A here. Okay, let's say we have, that's a hexagon. And we have 6 sides. And we have 6 points, vertices. Okay, we have 6 points. Okay, 6 sides, 6 points. I want to connect it to, from this point A, to connect it to other points to make lines, but I cannot connect the adjacent two. Okay, I cannot connect to the adjacent two. So what I can connect will be this one, and this one. So how many lines I actually can make? It is 3. Okay, it's 3 because there are 6 points in total. I cannot connect to myself, that's less than 1. I cannot connect to 2 adjacent ones because that will be the 2 sides. So that's minus another 2. So 6 points subtract 3 will give you, there will be 3 lines what you can draw. Okay, so I can draw 6 minus 3 lines from point A. Okay, exclude itself, exclude the 2 adjacent ones. I can draw 3 lines, okay, to other vertex. And how many triangles I can make? I can make 6 minus 3 plus 1 triangles. Okay, I can make 6 minus 3 plus 1 triangles because that's 4 triangles. I draw 3 lines, I can cut the shape into 4 parts. Right? I draw 3 lines, I can cut the things into 4 parts. So I can draw 4 triangles. Okay, how large, what's the sum of triangles? Okay, the angle of sum is 180. Okay, there are 4 triangles. So the sum of all those angles will be 180 degrees times by 4. Okay, 180 degrees times by 4. So all of those angles add together, that will be the inner sum of this hexagon. Okay, all of that add together. So it's all the triangles summed together. So now if you have n lengths, okay, that's with n length and n vertex. So I can draw n minus 3 lines. I can make n minus 3 plus 1 triangles, and each triangle will be 180 degrees. So that's the inner sum of all the angles. So that's 180 degrees n minus 2. Okay, that's 180 degrees times n minus 2. So n minus 3 will be how many lines you can draw from one point. Plus 1 will be how many triangles you can make. n times 180 is the inner sum. And you have all the angles summed together, which is 180 times n minus 1, n minus 2. Okay. The next thing is regular polygons have equal size and equal angles. A single interior angle will be n 180 times n minus 2 divided by n. So let's still draw a hexagon. Okay, that's a regular hexagon because all the lengths are the same, then all the angles needs to be equal as well. Okay, that's a regular hexagon. And the inner sum of this hexagon will be 180 times 6 minus 2, right? n minus 2 is the inner sum. And how many angles are there? There are 6 angles. So I will divide by 6. Okay, that's each angle. Okay, divide by 6, that will be each angle. How large is each angle? Okay, so if it's a regular shape, I can find the single angles. But if it's not regular shape like this one, I won't know how large is each angle. We need to calculate by different ways. Okay, next one is talk about exterior angles. And exterior angles is the supplementary to an interior angle. Exterior angle theorem for triangle. The exterior angle is equal to the sum of the 2 opposite inner angles is equal to the sum of 2 opposite interior angles. So let's do this. I'll draw a triangle. I'll draw 2. Let's do a triangle like this. Okay, let's do a normal triangle. Let's say we have point A, B, and C. What is exterior angle theorem talking about? It's talking about we have the angle C will have exterior angle here. Let's call the C dash. Let's call this angle C dash. That's the exterior angle. That angle will equivalent to angle A plus angle B. okay, will be the other two angles inside. So C dash will equals to angle A plus angle B. That's the exterior angle theorem I'm talking about. So B can have exterior angles as well. So if we have B dash here, so B dash, angle B dash will equals to angle A plus angle C. Angle A plus angle C. Okay, so same as angle A, so if we go that way, A dash. So angle A dash will equals to angle B plus angle C will be equals to the other two angles inside the triangle. How we can prove on this? Okay, how we can prove on this? That's pretty easy to prove. Triangle, because it's a triangle, so the inner sum will equals to 180 degrees. Okay, angle C dash plus angle C will equals to 180 degrees. So what we can see here? Okay, so angle A plus angle B will equals to 180 degrees. Subtract angle C, and angle C dash will equals to 180 degrees. Subtract angle C as well. So angle C dash will equals to angle A plus angle B. Okay, that's how you prove this. Okay, that's inner summation for triangles, and that's a straight angle. Okay, that's a straight angle. C plus C dash, that will be the straight angle. Okay, that's 180 as well. So A plus B will be 180 subtract C, and C dash will be 180 subtract C as well. So because they're all equivalent to the same thing, then C dash must be the same as A plus B. Okay, any questions? No? Okay, if there's no questions, can we have a look at the examples below? Okay, let's have a look at the examples below. Okay, find the values of the polynomial. So that's finding the polynomial A. Okay, let's draw a line past point C. Let's say that's F. So the first thing I do is draw CF parallel to AB and DE. Okay, draw CF parallel to AB and DE. Okay, now you start to talk about that. Because AB is parallel to CF, so angle ABC will equals to angle BCF, that will equivalent to 25 degrees. Because CF is parallel to DE, therefore angle FCB plus the angle CDE will equals to 180 degrees. That's the cointerior angles. Okay, that's the alternate. That's the cointerior. Okay, alternate and cointerior for the 181. So triangle FCD will equals to 180. Subtract 140 degrees. That will give you 40 degrees. The angle A, the polynomial is angle A, will equals to the angle BCF plus the angle FCD, and that equals to 25 degrees plus 40 degrees. That gives you 65 degrees. Okay, you need all this reasoning. Okay, because of that, so that angle equals to how many degrees? Because another two pair of lines paralleled, so your cointerior angles are sum up to 180 degrees. So therefore, what that angle should be, and then you add up those two. Okay, next one. Give reason why A, B, and D, E in this diagram are parallel. Okay, I want to prove. Okay, prove A, B parallel to D, E. Okay, that's what I want to know. Okay, how we can prove two lines are parallel? If we can prove alternate angles are equal, or if I can prove corresponding angles are equal, or if I can prove cointerior angles add up to 180 degrees, then I can prove two lines are parallel. That like going back ways, okay? If alternate angles are equal, if the two cointerior angles sum up to 180 or corresponding angles are equal, then you can prove two lines are parallel lines. So now let's have a look at, if I can prove this angle equals to that angle, if I can prove that, then those two angles will be equal, right? Those two lines will be parallel. So how we can prove for that? So let's first talk about, because AB equals to C, let's say because CA equals to CB, those two lines are equal, like that's given to you. Okay, CA equals to CB, so angle A equals to angle B. Okay, angle A equals to angle B. Because CD equals to CE, okay, those bottom two equals, so angle D equals to angle E. Okay, you have two pairs of equal angles, but what you have is this one equals to this one, and this one equals to this one. You still haven't proved D equals to B or A equals to E yet. Okay, so the next step, what you will do is, also, triangle ACB will equals to triangle DCE, because that's vertical opposite. Okay, that's vertical opposite. Those two triangles are equal. Those two angles are equal. And now you can say in triangle ABC, angle A plus angle B plus angle ACB equals to 180 degrees. So 2 angle A will equals to 180 degrees. Subtract the triangle ACB. Because angle B is equals to angle A, we have a proof on that before. Okay, so 2 angle A equals to that. So what angle A equals to? That equals to 90 degrees. Subtract a half of angle ACB. Okay, so you subtract that vertical and you divide that by 2. I want to make what A equals to. So A equals to 90 degrees. Subtract 1 onto angle ACB. Okay. Let's keep going here. In triangle CDE. Okay, in triangle CDE, angle D, let's say angle E plus angle D plus the angle DCE will also equals to 180 degrees. Because D and E are equal, so 2 angle E will equals to 180 degrees. Subtract DCE. So angle E will equals to 90 degrees. Subtract the triangle, half of the triangle DCE. Okay, and because ACB and DCE are equal, so therefore angle E will equals to 90 degrees. Subtract a half ACB as well. Okay, DCE and ACB are the same, so I can change DCE to angle ACB. Okay, they are the same value, so I can swap them. Okay, now have a look. Okay, there are in the same expression. They are in the same expression. So angle A equals to angle E. Therefore, AB parallel to DE. Okay, because the alternate angles are equal, therefore they must be parallel lines. Any questions? Okay, next one. So now we have, what shape is that? 1, 2, 3, 4. Okay, we have 4 lengths that is like the sum of interior angles equals to, that's a quadrilateral, so it's 360 degrees. Okay, everything add up equals to 360 degrees. And what's that equals to? That equals to 180 subtract x plus 100. Okay, that equals 180 subtract x plus 100. That equals to 80 subtract x. Okay, 80 subtract x. Okay, so now let's sum all those angles, all the inner angles, not the outside one. So we have 2x plus 55 plus 120 plus 90 and plus 80 subtract x. That should give you 360 degrees. So we have 2x and we have subtract x, we have x. X will equals to 360, subtract 55, subtract 120, subtract 90, and subtract 80. So that's x equals to 360, subtract 55, subtract 200, minus 90, so 290. And x will equals to, let's go 70, subtract 55. That subtract that first, give you 70. And x will equals to 15 degrees. Okay, x will be 15 degrees. Okay, the polynomial is 15. Any questions? No? Okay, the last one. Okay, for this one, let's have a look at this angle B. Okay, let's have a look at angle B. We have A, B, and C. If we know B, we will know A. Okay, 360 minus B. But because in this shape, we have 2 unknowns, which is hard to solve. So let's draw a parallel line here. Okay, let's draw. Always try to think about draw parallel lines. Okay, that will be parallel to that. So this angle will be 180 subtract 35. Okay. Let's do the other way. Let's do another easier way. Let's think about A. So this will be 35 degrees. And this will be 75 degrees because parallel lines and I have alternate angles. So 35 and 75. So A will equals to 35 plus 75. That give you 110 degrees. I can also do the other way. Okay, I can also do the other way. I just think about there's too much like calculations. So I choose to do for A. So B will be 360 subtract 110. That is 250 degrees. Okay, now we're looking for C. So how many lines are there? So 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 sides. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6, not 7, 6. So 1, 2, 3, 4, 5, 6. Okay, 6 lines. Okay, 6 lines hexagon. So the sum interior angle sum is 180 times 6 minus 2. Okay, I can make 4 triangles here. That times 4, that's 720 degrees in total. So 35 plus 250 plus 75 plus 160 plus 90 and plus C. So C will equals to 720. Subtract all these sums here. Okay. All the sums 35, 250, which is B, 75, 160, and 90. Okay, the sum is 720. Okay, the sum is 720, so just subtract that. 250, 500, plus those two give you 110. So 720 subtract 610, that is 110. Okay, that's for angle C. Okay, a little bit rushed, but like that's the answer for last question. Okay, that's the answer for last question.